Yeah, great. I'll come and speak to you later.
Thank you very much.
Fabulous. Thank you very much.
Just on the beach clean note, I think the Great British Beach Clean is coming up. Might be wrong, but please get involved. And now I would like to welcome Volker to speak on underwater noise.
Right. Good afternoon, everyone. My name's Volker Deecke. I'm from the University of Cumbria as well. My background really is underwater communication of cetaceans, but by necessity branching out into the things that interfere with it, including underwater noise. So what I'd like to do today is tell you a little bit about the issue, because I do feel there's a lot of misconceptions about underwater noise. Show you some information on the Irish Sea, but also hopefully end with some solutions to the problem. The first thing is that it's really important to understand that noise underwater is a very different thing from noise in the air. And I think part of the problem arises from us taking our terrestrial experience about noise and trying to extrapolate to the underwater, and that doesn't work. And that's mostly because sound travels so much farther underwater. It's also much faster underwater. And so things that may cause mild annoyance in the air are actually having much more dramatic effects underwater. Because noise is such a useful sense underwater, or sound is, most marine organisms, or many marine organisms, have evolved ways to use sound for essential life processes. Things like navigation and orientation. So you've got even fish larvae or coral larvae using sound to find good, habitat patches. Animals use sound to detect predators. Animals use sound to find food, either through passive listening or, like this dolphin, through echolocation, sending out a relatively loud sound pulse, but then listening for a very faint echo coming back from that. And then ultimately communication that involves finding a mate. So even fish species like haddock are making calls in order to attract mates. Cetaceans like dolphins and other toothed whales are using sound to keep in touch. And that's not just something that they need to do. If a calf gets separated from its group because it's either had hearing damage or because the environment is too noisy, that calf will likely die. So underwater noise pollution can interfere with all these processes. Noise is not a new phenomenon. The underwater environment has always had noise. We're looking at wind noise, rain noise, ice noise in the polar regions can propagate surprisingly far. Underwater earthquakes are loud enough that they can cause hearing damage to cetaceans as well. And then you've got a very rich chorus of biological noise, including fishes and cetaceans making sound to communicate. However, humans have changed the underwater soundscape quite dramatically. The main sources of noise are shipping, some form of industrial activity that includes dredging of offshore wind turbines as they're being built, but also as they're operating, are generating noise. And then things like seismic surveys, and ultimately the military is causing noise using specific sonars to find submarines or setting off underwater explosions. And the problem we have is that we don't actually know what the ocean sounded like before we started messing with them. Because we started producing industrial noise from shipping, steamships even, long before we developed the first hydrophones, underwater microphones, to listen to sound. Hearing sensitivity matters, and underwater noise is a very nuanced phenomenon. Good hearing, underwater hearing, has evolved multiple times in the animal kingdom, and it's a very different phenomenon in, say, invertebrates that mostly use particle motion using hair cells of some form to sense movement in the water. Whereas if you look at the vertebrates and certainly the marine mammals are sensing pressure waves using some sort of very specialized ear-like structures. The fishes are intermediate. Some of them have functional ears to sense pressure waves, but others, they also have a sideline organ that senses particle motion. Even among a single group like the marine mammals, hearing can be quite diverse. And that means that noise that affects one species in one way will not have the same effect on another species. In the marine mammals, we've got the seals that have good hearing, we think, from about 50 hertz to 50 or 60 kilohertz. Our own hearing ranges from about 16 hertz to 16 kilohertz. Seals have much better higher frequency hearing. Toothed whales are high frequency specialists, probably as an adaptation to echolocation. They can hear sounds up to 120 kilohertz. And then the baleen whales, we believe, are low frequency specialists, although we don't actually have good data on baleen whales because it's not easy to get an audiogram on a baleen whale. But we do believe that certainly blue whales communicate in the 15 hertz range. So safe to assume that they've got quite sensitive hearing in that range as well. We think it extends to at least 10 kilohertz, possibly higher. What this graphic here shows is the different hearing sensitivities of different marine organisms in the top panel, and the sounds produced by different anthropogenic activities in the bottom panel. Allowing you to sort of get a sense of which sound type, which form of noise pollution will affect which type of organism. And the take-home message here is that, shifting to a different frequency in terms of noise pollution can solve the problem for one taxon, but actually make it worse for the other. When we look at the effects of marine noise, at close range, loud sounds can have lethal effects. There was quite a sobering study looking at plankton in the wake of a seismic survey vessel, suggesting that larval zooplankton was effectively killed up to 1.2 kilometers away from the air gun. So every time one of these seismic survey guns goes off, it punches a 1 or 2 kilometer wide hole into a plankton layer, which is quite sobering. At greater distances, underwater noise can cause permanent hearing damage. And obviously, if you're an animal that relies on its hearing, that can have sublethal or lethal effects. This is a study from the Wash in the North Sea, where a team led by Gordon Hastie at the University of St Andrews tagged 24 harbor seals during the construction of an offshore wind platform in the area. And from the 24 seals, the seals had geolocator tags, so you kind of got a sense of what exposure they experienced. And those seals, 3 of them probably experienced permanent hearing damage during the construction phase. So that's something to keep in mind. It's a cumulative effect. So, here you can see the individual pulses. Initially, the dosage goes up, but the seal doesn't actually fully recover. And then it's that second pulse of impacts that pushed the seal into the permanent hearing damage range. At greater distances, underwater noise can still produce effects in terms of temporary hearing threshold. That phenomenon when you've been at a very noisy event like a rock concert, the next morning you wake up and your hearing isn't quite right, but you will recover that during the day. However, during that time until recovery occurs, obviously feeding success could be reduced, a mating opportunity may be missed, and so on. And then distances of tens of kilometers for harbor porpoise, pile driving probably causes avoidance at distances of at least 30 kilometers or more, and that can then exclude animals from feeding habitat or make them miss feeding opportunities. So it's a very multifaceted phenomenon. Just wanted to show you some data on shipping noise in the Irish Sea. This is Saturday afternoon when I wrote this talk, and you can see it's a busy waterway. You've got centers of population density around this enclosed water body. You've got at least 20 ferries going at any point in time. You've got bulk carriers, container ships accessing the ports of Belfast, Cardiff, Dublin, Liverpool, supply vessels for wind farms, probably on the order of about 2,000 fishing boats registered in ports and harbors around the Irish Sea, and then an unknown number of pleasure craft. I'll also show you some data from the Marine Noise Registry. This is a publicly accessible website where loud impulsive noises like military sonar, not all of them are reported, but some of them are. Seismic surveys, sub-bottom sampling are being reported. And I'll just whiz through the last 10 years to give you a sense of what has happened in our backyard in the Irish Sea. So you will see the purple sort of in the Clyde. That's probably military exercises out of Faslane, the submarine base. We'll also see underwater explosions off the coast of mid Wales. And then you will see regular seismic surveys. You may have heard in 2022 seismic surveys to look for safe places if they exist for nuclear waste, those kind of things. Sub-bottom profiling is slightly more benign. It doesn't penetrate into the bedrock per se, but it does go into the sediment, and it's often done before the laying of an undersea cable or before pile driving started. You can see here a nice lull in 2020 during COVID, but since then things have picked up again, and we are looking at annual events of these high impact kind of noises going on. 2025 is partly stuff that has been done already, the military sonar, and the red line is a planned subsurface profiler later on in the year. Couple of take-home messages. I don't want to end on a bad note. I do feel it's a problem we can fix, but here are some things that I think we need to be careful about. First of all, language matters. Underwater noise is not just an annoyance. It does have, like any pollutant, I think we need to treat it like a pollutant. It has sublethal effects at close mid-ranges. It has lethal effects at greater ranges. And, our language as conservationists need to reflect that. Talking about, whale sound as chatter is not productive. This is not just something that the animals do to kind of have a bit of fun. These are essential life processes that are affected by underwater noise. I think we need to be vigilant. The Marine Noise Registry is very important. You can already look at what's planned in the coming years, but the Marine Noise Registry only logs reported noise. It doesn't log shipping noise. And so I think there is a case to be made for citizen science-based monitoring programs. You can now get these relatively cheap recorders that you can put on the seafloor for months at a time to record underwater noise and actually pick up some of the activities that are going on. What's really important to remember is we have solutions. We have ways to make ships much quieter than we could. The navies are all using them because they don't want their ships to be detected by enemy submarines. And we need to put the pressure out there to make that technology deployed on all vessels. Here is a really good example of very effective mitigation, a bubble curtain around a pile driving vessel. And the bubbles actually absorb most of the sound energy meaning it doesn't have that massive effect that can deafen a seal even at a distances of 6.9 kilometers. The other thing we need to do is work with the industries, and it's great to see some industry representatives here. Underwater noise is a multifaceted, a very nuanced phenomenon, and the problem is that fixing the impact on one taxon could actually make it worse for another. The other thing we need to do is make sure that the habitat is good, not just for the species that are currently here, but also for the species that should be here. We are seeing, fortunately, humpback whales coming back around the UK. So, let's give them the acoustic space to make the Irish Sea good habitat for them as well. Thanks very much. I know I went over.
Thank you very much, Volker. I think we have time for one quick question.
Yeah.
Not just an seismic, mention the impacts on planets. Has there been any studies done into the impacts on fish? The reason I ask is we're getting a lot of anecdotal information from fishermen on presence of seismic survey vessels in the East Irish Seas correlated inversely with sea bass numbers in particular. I just wonder if there's been any research.
I know there has been research, but get back to me. I'll look it up. I know the literature on cetaceans quite well, and it causes avoidance at distances of tens of kilometers, and sublethal effects in terms of hearing damage on the order of a kilometer. And so these seismic survey vessels, for example, need to have a marine mammal observer on board, and the air guns can't go off if a cetacean is spotted from the vessel. Cetaceans spend a lot of time underwater, so it's not 100%, but at least it's something. But the information on the fish is really interesting, and it'd be really good to follow that up. Thanks.
Thank you.
All right.
All right, and now I would like to introduce Carrie Rennie from Sea Search, and they also have a wonderful poster here, or pop-up banner, sorry, in the corner of the room, if you want to take a look at that. Welcome, Carrie.
Okay, I'm going to do something a bit differently because that's my style. Put your hand up if you've been scuba diving abroad anywhere. Okay, so what's that, about